Hello students, my today's lecture is on important topics, important questions on general principles and processes, isolation of elements for 2019 CBSE chemistry paper. This has 3 total marks, essay 231. First of all, you know that we are extracting these elements from the Earth's crust, and also C is also a source of these elements. What we have in the earth crust is mineral, ore and gangue. The definitions of this should be known to you for the examination. Important. You already know that there are large number of minerals, but it may not be possible to extract metals profitably from all the minerals. Therefore, we use ores. Ores are those minerals from which elements, metals can be extracted profitably. And gangue means their unwanted material which is present in the ores. There are a lot of impurities, sand, clay, etc. and other elements could also be present when we are extracting metals from the ores. They are called gangue, unwanted material. Now then, you know that most of the metals are occurring in the form of oxides, sulfides or compounds. Only few elements you know that which are existing like silver, gold, platinum or copper, etc. in the free state, which are not very reactive. Further, you can see that in our course, you will see there is a table 6.1 in the NCERT book, which has given aluminium, zinc, copper, iron, ores and their composition. It is important that you learn this table because sometimes they can ask you the name of the ores or their compositions of iron, aluminium. For example, aluminium, the chief ore is bauxite, which we are using. So learn that. Further, I am coming to principles of concentration. Very important that how will you remove unwanted material from the ores. There are many methods which have been used for concentration of the ore, removal of the gangue from the ore. One is hydraulic washing. It is mainly based on the difference in the densities or the specific gravities of the ore and the gangue particles. Gangue particles can be easily washed away with the water. Further, magnetic separation. If the ore is magnetic, some iron ores for example could be magnetic, so we can use magnetic separation. This is based on difference in physical properties of the metals, ore and the impurities. Froth flotation is the most important. There will be definite questions from froth flotation from our past experience of the board papers. We know that what we are using, these are mainly used for sulfide ores, and in the NCERT book complete information is given. You must study froth flotation because I will be discussing a lot of questions on this very soon. Froth flotation process where we are using pine oil and it's based on the wettability. Sulfide ores are wetted by pine oil and gangue are wetted by the water. The leaching of alumina from bauxite. Most of the bauxite contains impurities like SiO2, iron oxides and titanium dioxide. Concentrated sodium hydroxide is used. A complete method and equations are given in NCERT book. Important. Leaching of alumina important. Please note down all the equations from NCERT book. Leaching of silver and gold by sodium cyanide, ACN, oxygen, metal, which is also then obtained by zinc using as a reducing agent. Very important, very important. I have given on this side also this oxidation reduction method for the extraction of gold and silver, where I have given equations also that it is a redox reaction. Gold is oxidized and silver is also oxidized by the cyanide ions to Au plus or Ag plus. Very important. And once you get the complex AuCN2 minus or Z, then this complex, from this complex I will use zinc as a reducing agent and will recover the gold from this method. Very important equations for silver and gold for the coming examination. Further, extraction of crude metal from concentrated ore. Concentrated ores are oxidized to form oxides because thermodynamically it is more favorable to reduce the oxides, and you have carbon coke plenty which is cheaply available. Therefore, it is very convenient as well as thermodynamically feasible as well as profitable to form oxides and then reduce them by coke. Here you are using conversion of metal to oxide, then reduction of the oxide to metal. Calcination and roasting, what is the difference between the two is important question. Calcination is mostly done for the carbonate source. We have given example of that. ZnCO3 gives ZnO plus CO2 in the absence of air, and volatile impurities will form gases and evaporate. Water will also evaporate. Then roasting is done for most of the time sulfide ores. Sulfide ores are converted into oxides by heating in air or oxygen. As you can see, zinc sulfide, Cu2S, these are being roasted. Reduction of oxide to metal is important. Then you have seen carbon is very important in this case. Coke which we are using, it is cheap and easily available. Metal oxides are reduced to metal by using coke, carbon, and there are other methods also. We will see that thermodynamic principles of this involve delta G is equal to delta H minus T delta S. In the NCERT book you will learn AIIMS diagram is given, which are plots of delta Fg versus temperature for the formation of the oxides of the metal. The basic principle is that the metal oxides are formed and they will be reduced by some reducing agent like carbon monoxide, or carbon dioxide gas is also formed during the process. The important thing about the AIIMS diagram is that the delta G for the overall net reaction should be negative. It should be negative for the reaction to proceed. Therefore, you will see in the AIIMS diagram the plots that at different temperatures carbon could be effective as a reducing agent, carbon monoxide could be used as a reducing agent. There could be a question based on that. So you have to learn this. That you will see in the graphs, the lines which are lying lower will be able to reduce the one above them. Further, you see in the extraction of iron, we are using blast furnace. You should learn the different equations, different reactions which are taking place in the blast furnace in the extraction of iron at different temperatures. They are given in the NCERT book. Important point is that basically iron oxide is being reduced by coke to form iron, and carbon monoxide gas is being formed. At the same time, the chief impurity in the iron ore is silica oxide, SiO2. So for this, limestone is added. Important question: what is limestone? Why it is added? It is added. It is a flux. It produces calcium oxide, which will react with SiO2 to form CaSi3, which is a slag. The slags are very important. They can be easily removed. They floats over the molten metal, therefore protects the metal from further oxidation, and impurities are removed, slagged out. In the iron, you will see in the book there are three forms: pig iron, cast iron, wrought iron. Pig iron contains about 4% carbon. It is not in much use, but cast iron is very hard and it is brittle. It has 3% carbon. It is possible to convert pig iron into cast iron. How you can see the book. Cast iron and the most purest form of iron is a wrought iron, which is a commercial form, which is malleable and ductile, as iron has great uses of forming sheets and bios, etc. Extraction of copper from cuprous oxide, copper 1 oxide. You will see in the graph of a AIIMS diagram, delta Rg versus T for cuprous oxide is on the top. So it is very easy to reduce it by heating. Hence, it is easily done. And in this, it is easy to heat it by coke below 5 to 600 Kelvin, and you will be able to get copper. Further, in the extraction of copper, you will see the main impurity are iron. So iron sulfide is oxidized to iron oxide. Therefore, we have to use a flux which is SiO2. So SiO2 is a flux, reacts with the impurity FeO, which is the chief impurity in the copper ores, and it will form a slag FeSiO3, important for exams. Extraction of zinc from zinc oxide is easy. You can use coke, but this will need higher temperature than copper, as you can see in the AIIMS diagram that it is lying lower than copper. Electrochemical principles very important. Hall-Heroult process. Electrolysis of bauxite diagram has been given. Hall-Heroult process has been asked many times, where we get pure alumina by electrolytic process. In this, cryolite is added in order to reduce the melting point of the bauxite to make it more conducting. Important point. And you have Na3LF6 or CF2 as a cryolite. Further, graphite anodes are used. What they will do? As the electrolysis will be done, graphite anode and steel and carbon electrodes is there, which is a cathode. When the reaction will take place, you will find oxygen gas is liberated. It will react with the graphite carbon and form carbon monoxide and carbon dioxide. In the process, anode will be burnt away and aluminium will be produced. The reaction is 2Al2O3 plus 3C gives 4Al plus 3CO2. Further electrode reaction at anode cathode are given in the book. You can read them. Copper from low grade copper ore is important because the cost is very important when we extract metals. Here you find that using scrap iron, we can get copper from low cost coppers. As you can see, iron is more active than copper 2 plus. It will be able to reduce copper 2 plus to copper, and this is a reaction. Also, I can use hydrogen gas for the reduction of copper 2 plus ion. This is a cheap method which is available. This is preferred over zinc plus because zinc is more reactive, but zinc is costlier than this, and zinc will also be able to zinc is also more reactive than iron, so it will also oxidize iron to iron 2 plus. Further, I am said oxidation reduction for silver and gold, very important question. Cyanide process. Cyanide is used in order to extract gold and silver. Here the reaction is a redox. Again I am repeating, gold is oxidized to Au plus, silver is oxidized to Au plus. A complex which is formed is AuCN2 minus. Zinc is acting as a reducing agent. It is going to displace gold from the cyanide complex or silver from the cyanide complex. Very important. I am coming to the refining of metals. The metals which you obtained are not in very high state of purity. It is important that we should be able to obtain in high state of purity. For this, refining is important. Very favorite questions for exams are always the methods which are used are based on the differences in the properties of the metals and impurity. Distillation, you see that metals which have low boiling points which can evaporate readily like zinc and mercury, they can be distilled. Liquefaction means low melting point, they can be separated from the impurities. Electrolytic refining has been asked many times. You know, copper electrolytic refining or zinc electrolytic refining is done. Impure copper is made the anode, pure copper cathode. The oxidation and reduction reactions takes place, and copper sulfate is my electrolyte, and you will get pure copper at the cathode. At the same time, anode mud is important because when it falls down, the impurities which are there in the copper could be antimony, selenium, tellurium, and even some costly metals like silver, gold and platinum. It is good because if we get these costly metals, they will recover the cost of the electrolytic refining of copper. Joule refining is very important question. What is the principle of joule refining? It is mainly used for germanium, silicon, boron, indium. You name impurities are more soluble in melt than in the solid state of the melt. So if we heat and the burners are movable burners, what will happen? The impurities will go on one side with the melt and solid will remain behind. You can cut them into two pieces. Very important. Vapor phase refining, very important because when you can form a compound which can be vaporized and then it can be decomposed to give the metal, this method can be used. Mond process, important for nickel. I have given the reactions also. Give the reaction of the Mond process. Nickel plus 4Co at 350 forms a compound tetracarbonate nickel. This can be easily vaporized, and after this we can decompose this at 470 Kelvin to get pure nickel. So we are able to form a compound with the reagent CO which can be vaporized, and then you see that this can be decomposed. Van Arkel process important for zirconium and titanium. It removes oxygen and nitrogen as the main impurities. Zirconium reacts with iodine under vacuum conditions. This is done to form zirconium tetraiodide at 1800 Kelvin. In the presence of tungsten, it is decomposed to give zirconium. Very important. What is the principle of chromatography? Here, in all these, the principles will be asked because you see the topic is general principles. Chromatography, when different components are differently adsorbed on an adsorbent. For example, column chromatography, the column of alumina is used, and if you put a mixture and in some liquid, you will see that different components will be adsorbed to different heights, different extents, and they can be eluted then with a particular element, solvent, and separated. So this is mainly done for purification of elements which are present in minute quantities, in small quantities, and chemical properties of the elements are not very different. Further, you will see the uses of metals like aluminium, copper, zinc, iron. This is given in the NCERT book. Certain alloys, because metals have great application, great uses in our everyday life, and their alloys are very important. German silver has been asked sometimes. Copper 25-30%, zinc 25-30%, nickel 40-50%. Coinage metals like brass and bronze, copper plus zinc, bronze, copper plus tin. They have been asked. Now I will be reading some of the important questions, which are very important questions for the coming 2019 on isolation processes of the elements. First question, differentiate between mineral and ore. You know that from ore we can extract the metal profitably, and they are both present in the crust of the earth. What is the principle of froth flotation? Mineral ores are weighted, mainly sulfide ores are used by pine oil and gangu by water. What is gangu? Unwanted substance or impurities. What is the function of collectors in froth flotation process? Collectors like pine oil, fatty acids, they enhance the non-wettability of mineral particles. Why only sulfide ores are concentrated by froth flotation process? because sulfide ores are wetted preferentially by fine oils and impurities by water. What is the role of zinc in the extraction of Ag and Au? I have already explained. Zinc is used as a reducing agent. So the cyanide complexes are there. Zinc reacts and displaces gold. Zinc acts as a reducing agent. Name the method used for refining of copper. Electrolytic refining. Name the depressant used to separate ZnS and PbS ore in froth flotation process. As you will read the froth flotation process, I said is important. You see that if there are two ores, ZnS and PbS, you can add sodium cyanide. It prevents ZnS from coming to the froth. Name the chief ore of aluminium and zinc. So aluminium bauxite give the formula zinc blend ZnS, Al2O3 XH2O for aluminium. Which reducing agent is employed to get copper from least low grade copper? Scrap iron or hydrogen can be used. This is the cost is very less. Name the method used for refining of nickel. Nickel refining, we have shown what we are doing. Heat it with carbon monoxide, which is a very stable complex which is formed, separated and decompose this. The reactions have been given. Important for nickel. Name the method used for vapor phase refining of impure titanium. Impure titanium I have already given. Van Arkel process. Zirconium plus 2 iodine, ZrI4 decomposed to form zirconium. Important. Describe the role of SiO2 in the extraction of copper from copper. The main impurity in the copper is, when you get copper matte, is iron sulfide. This is oxidized to iron oxide. Iron oxide is then reacted with slags SiO2 to form the flux. Right chemical reaction involved in the extraction of Ag from its ore or Au from the ore. Two reactions. Silver and gold, very important. I have given many times. Cyanide process. Give the principle of zone refining and give the principle of chromatography. Very important. We have already discussed and given you this. What is the role of graphite rod in electrometallurgy of aluminium? I have already told you that when we are doing the Hall-Horrod process for the extraction of aluminium from bauxite, the graphite anode will be burnt away, and what you will get will be the aluminium process. Explain the role of cryolite in the electrolytic refining or reduction of aluminium. You know cryolite decreases the melting point and increases the conductivity of Al2O3. Name the method for refining of germanium. Germanium, you know, we have already given zone refining. What is the role of coke in the extraction of iron from oxides? Coke reduces carbon dioxide to carbon monoxide and helps in the reduction of iron. The equations are given: CO2 plus C gives 2CO and 3Fe2O3 plus CO gives 2Fe3O4 plus CO2. Fe2O3 plus CO gives 2FeO plus CO2. FeO plus CO gives Fe plus CO2. In the NCERT book, the equations are given. You have doubt, go through it. Which is the purest form of commercial iron? Wrought iron. Describe the vapor phase refining of the metal and zone refining. We have already discussed. Important question. Many questions are repeated, as you will see the previous board year papers. Explain the electrolytic refining. Copper, you can give an example. We have already shown impure copper anode, pure copper cathode, copper silver electrolyte. But froth flotation process, what is the principle? We have already said sulfide ores are wetted by pine oil and gangu by water. Principle of chromatography we have discussed. Principle of distillation we have discussed. Describe the preparation of cast iron from pig iron. Cast iron is made by melting pig iron with scrap iron and coke using hot air blast. Cast iron contains 3% carbon, hard and brittle. Describe the principal preparation of pure alumina from bauxite. Leaching process I have already told you. You can see the reactions in the book. The main impurities are SiO2, TiO2, FeO. Out of C and CO, which is better reducing agent at a low temperature range in blast furnace to extract iron from oxide ore? Important. Use the Ellingham diagram. You will see CO is a better reducing agent at a lower temperature. We always prefer lower temperatures because they will cost us less. Higher temperatures are more difficult and we will have to spend more money to get higher temperature and bigger apparatus. What is the difference between roasting and calculation? We have already explained. Give reason. ZnO can be reduced to metal by heating with carbon, but Cr2O3 cannot be reduced by heating with carbon. Use Ellingham diagram. Delta Rg for ZnOC couple is negative, but delta Rg for Cr2O3 couple is positive. So the reaction delta Rg must be negative for the reaction to be spontaneous. What is the role of collectors in froth flotation process? Collectors like pine oil, fatty acids enhance non-wettability of sulfide ores. Important question. What is the role of carbon dioxide in the extraction of aluminium from Al2O3? You know, if you will see the NCERT book,
The aluminate which is formed is neutralized by CO2 and Al2O3 is precipitated in hydrated air. Equation has been given in NCERT book. Check this out. What is the composition of copper matte? Copper matte contains Cu2s and Fe(S). Although thermodynamically feasible, magnesium metal is not used for reduction of Al2O3. According to Elingham diagram, magnesium can reduce Al2O3, but magnesium is a costlier metal. Cr2O3 plus 2L gives Al2O3 plus 2 chromium. Thermodynamically, it is feasible, but why it does not take place at room temperature? Because the reaction needs energy of activation. So unless activation energy is provided, reaction will not take place. That is why higher temperatures are required. Why solidified copper obtained has blister appearance? This is due to presence of sulfur dioxide gas which is there in this. Okay, thank you. I hope this will serve your purpose, and only 3 marks are there. One mark small questions will be there. Revise, repeat, and go through the lecture which I have said to you. Watch my videos very carefully. They will help you a lot in the coming paper. A lot of questions are expected, and my best wish is keep on subscribing my channel, and my purpose is only one, to help you. And I tell you that each one of you can be 100%, and if you think positive, believe positive, act positive, you will do it. Keep yourself relaxed, keep yourself motivated, stay healthy and fit, and go for examination. My best wishes. Okay.